So the recording is starting right now, and there's a little thing that pops up on my screen letting everybody know that, for me to let everybody know you're being recorded. So if you say something, you will be forever caught in my class's history. And what happens is at the end, if I turn it off correctly this time, the recording should be listed in the out in the Teams chat box, and it shows the recording at the very end, so you'd be able to go back and watch the recording if it's there. I'm also going to try, if there's time, to post them up on YouTube so that they're forever available there. Well, that being said, I am being required by all the way up from the vice president all the way down, from the president all the way down, that I'm taking attendance at these classes. So we're going to be treating it just like a normal class. So you're expected to show up to class and you'll have attendance taken. So you show up late and you get marked late, just etc., just like normal. Because there's a lot of science that shows that participation in the online class is directly correlated with your class success. If you don't show up, it's just like a regular class, you're going to do worse. So first thing, I guess that's the first thing, is making sure you understand the video is going to be recorded for all of these lessons, and hopefully I don't have any hiccups along the way like I did with the practice session last night. Second thing, I'm going to share, let's see. Page right here, I think. All right. So everyone should be able to see my Canvas page. In the modules, I've obviously, some of you either logged into Teams or saw Teams, but there's a link to this Microsoft link Teams page here. I also put a link in here for the OneNote page. So what I'm planning on doing is using OneNote to run through some of the problems, the in-class problems. And if you add OneNote to your notebook list, then you should have all the answers that I write up. You should have the answers permanently, so you can always refer back to them. I've also added useful files for the online class, how to enter Teams. Some of you are here, and some of you might need help. So when we're going through, if you have any other problems with Teams, we're going to be using a lockdown browser and lockdown monitor for our exam. I'll show you in a few minutes, but actually right below here, there's a sample practice exam. And with this sample practice exam, you're going to just see what you need to do in regards to the types of questions that are in the exam. You need to download Lockdown Browser through the link that's in this exam. If you just Google Lockdown Browser and download it, you will likely download a version of Lockdown Browser for some other university, and then you won't be able to take the exam. So you need to make sure you do that. You need to work through this practice exam to make sure everything is configured properly on your computer. That's going to be your homework assignment before Wednesday, is to run through the practice exam. You see down below the practice exam is the show your work submission. So a lot of people were worried that with the practice online exam, we won't have the ability to have partial credit. So what I've decided to do is I'm going to be providing essentially a blank sheet of paper with numbered sections so that you can show your work for each individual problem. And then what you'll do is, just like you do for the homework, you use Office Lens or some other scanning app, scan the document immediately following the submission of your exam, scan the document, and load it within a few minutes through this submission link. So I'd like you all to actually practice that when you work through the practice exam here. If you actually take the time, even if you just write scribbles on a sheet of paper, take the time to scan in, three or four pages, and then submit the document, just to show, give you a picture of how long it's actually going to take for you to run through the entire process. If you having any other problems, and you can also always enter the exams through the assignments tab. So if you go to your assignments tab, I just put the practice exam and practice submission at the top of the assignments tab. All right, so you should be able to do it there as well. The OneNote, you can see if you click on the OneNote link here, and then click on the link within the OneNote page, it should open up a new tab, which is going to be My Notebook page. And once that opens, it's taking a little while here. I think we're bogging down our network. All right, once you're logged in, you can see that the page shows up here. What I'm going to be doing along the way is simply going to be writing, I can write directly on the documents. So that's how I'm going to work through the problems, is simply by writing directly on these documents. And that this should be saved permanently in OneNote, and if you have the link, you should always be able to access it. So this should be able to help if you're working through problems during in-class problems and have questions. And it also helps for asking questions during class. All you have to do is unmute yourself, and you'll be able to ask questions. Unfortunately, my phone falls asleep so frequently that I'm not able to see all of the typed questions. So I think it might be better if we continue, if you just simply voice in and unmute your phone. I am wearing headbuds, so the feedback should be minimal. If you have headbuds, you should probably put them in, and then we can, can actually keep it open the whole entire time. Let's see. So I'm just looking at comments. Yes, Freddie, you should get OneNote. Everybody should get OneNote. You have access to, well, OneNote's free no matter what, but you have access to it through the university account. And you always should be logging in, obviously using your university email. It'll make life a lot easier for all of us. Let's see, who else? So let's see, has everybody else showed up? Yes. Brian's here. Hi, Brian. Let's see. Give me 1 second. Jason's here. Hi, Jason. All right. So again, if you ever want to comment along the way, I will review the comments every once in a while in the little chat box. So if you just click on the chat box, and that should allow you to at any point in time go directly to it should leave a message here for you, so that you can then ask anything you want, and I will answer it. But again, if you want, just unmute yourself. Might be worthwhile. Can everybody take a couple seconds and actually please write hi if you haven't written anything yet in the chat box, just to show me that you know where the chat box is. There it is for everybody, I think. Let's see. All right, great. What else? OneNote exam. Oh, one last thing. You can all use your cell phones, and take your cell phones, and I would suggest that you download the Microsoft Teams app on your cell phone. And here's why. And so in addition to logging in with your computer, if you use the Microsoft Teams app on your cell phone, then you'll be able to, if you're logged into the session and we're working on a problem and you're struggling on the problem and you have a question, one of the things you can do is you can use the camera function on your cell phone to show me the page in front of you. So you'll actually be able to share the page that's directly in front of you. Just, there's a share button in that tab just to the left of the conversation button. You can share, you'll be able to share your page. This will also be useful in regards to if you're needing any tutoring, either working with me remotely or with tutors. You simply be able to share, and you can hold your phone directly over your notepad. It'll look a little bit something like this. Let me show you what I'm talking about here. Right, so let's see. I'm just joining the meeting. See. I'm going to mute myself here though. Oh, feedback's gone. Let's see. There we go. I had to mute learning. You have to actually mute your audio as well. But anyway, let me share my camera. So you can see here, what that allows me to do is simply hold my camera up above, and you can see that all I have to do is simply, you can share the screen. Actually, is it sharing with everyone? Are you all able to see my camera right at the moment? Anyone? It doesn't, because I can't see it. No. Okay, let me figure out what's going on here. Oh, here it is, video. I have to start presenting. There we go. You actually have to click on a video button, and then you click start presenting, and now everyone should be able to see it. So you need to be steady, because there's a time lag. So you'll be able to work with, probably with tutors and with me if you have any questions along the way. So you can just set up an appointment with me, and we can simply go and work at it through this way. So I think that's going to be kind of a neat feature. And my guess is there are probably a lot of people who still don't know that that even exists. So you might even be able to share it with some of your professors in other classes or fellow students. So something that I just discovered over the weekend. All right. Let me think. So I got all that exam. Questions? Does anybody have any questions first before I get started with the PowerPoint? You can either unmute yourself or type it into the chat box. No questions. I actually just thought of something else that was probably going to be of interest is the, and this you'll have to learn along the way. So when you run through the practice exam, The lockdown browser, again, you'll need to download that. The reason you need to run through it the first time is you'll need to get used to the lockdown monitor. And lockdown monitor will ask you to use your camera on your laptop to look around your local area. Basically, you're going to be picking up your laptop, kind of like so, and you're going to, look down at your desk. You're going to look back at the wall. You're going to hold it around. Look down at your desk on the other side. Look over here. Look up, and you point down at the ground just to make sure that there's nothing underneath. Anybody sick and dizzy yet? So you'll have to, record. It basically records to show that you have no one else hiding under your desk, feeding you answers. No gremlins hiding, and it allows you to, then move on. You're also going to need your IDs because it asks you to scan a copy of your ID, and during the entire time, it will be recording you while you're taking the exam, and it will, which also requires that you sit in front of your exam the entire time, if you have any reason that you need to get up, then you would explain that to the camera before you get up, and then get up, and then obviously return back because there's face recognition built into it as well. So there are several things that you'll need to do for the exam along the way. So question is there a specific time we have to log in to take the exam? So yeah, you'll have, it'll be a time period, so I can't let the exam time go on forever for you, just like in normal sessions. So you'll probably each be given a certain period of time. I'm not sure, it'll be probably at least a couple hours, and depending on the length of the exam and the like. So, but it will probably still have somewhat of a flexible schedule, considering that you will still have other classes running at the exact same time. So that's the plan right now. We're all learning as we go along. Hopefully this works out. So the scrap paper that you're going to be working on is going to be the sheets of paper that I will be providing for you. So you'll have to print out the show your work sheet. I haven't had a chance to make one yet. I will, and I'll post it and show it to you beforehand. So there'll be a show your worksheet that you'll use as essentially your scrap for writing out and doing all the answers. If you need, are you asking for additional scrap on top of that, Cameron?
Hi, Dr. Marosa. I was just wondering, with the scrap paper that you provide, since we're going to be writing on it for the exam with the camera, how would that really work?
So the camera itself is not going to see you writing, right? So you'll obviously have a cleared desk, so you're going to need a cleared space. So you won't be able to see you. It'll see that you're looking down, writing on your sheet of paper. So it'll record you and see that you're looking down and obviously writing along the way. And then what you're going to do is immediately following the exam, you're going to scan that using office lens with your phone or something. So be prepared. So have everything ready. That's actually going to be one of the first questions I have on the exam is, are you ready? So to make sure that you actually have everything you need, you're going to need everything ready to go. For those of you who might not use office lens, you might use something else. You may need some other access to a scanner or something like that. That's fine, but you just have to let me know beforehand. Can you scan from the library? As long as you can, get up, walk over to the library, scan, and send while you're still sitting in the library. It's going to take you a few minutes to get there. That brings me to a whole nother point. I mean, how many of you are actually going to stay on campus? I don't want answers yet, but something to think about. There's just as news for yourself. I'm infatuated this from a pure scientific perspective, so I've been tracking this since back in January. The recent document came in from Holland, so there's a Dutch study basically showing that over 50% of the people are younger than 50 years of age. They're getting it. There's also currently an outbreak of this on Nova Southeastern's campus, so with a bunch of 18, 19, 20-year-olds. So you are not immune. You might want to think about that in regards to yourselves and decisions that you make. No, you don't need to send it in before the exam ends, and you're going to end the exam, then go and you can scan it. But there's the exam times you, and it'll show your timestamp as to when you finished, and then you'll need to scan it and send it immediately after, which within a few minutes. So hence the timestamps need to be close to one another. Yes, Freddie, you can use the same app for the homework, whichever app that is. Obviously, you need to make sure it's not blurry if you want partial credit at least. Yes, you'll still get a cheat sheet. So with all of this, obviously, a lot of you are going to have to start printing out a lot of this material. I'm trying to make decisions myself. I'm on campus right now in my office, but I'm not planning probably to keep coming to campus for very much longer. It's the scientist in me. I understand enough about this disease and about what's going on that right now we're at only a few cases here in Collier County. By next week we're probably going to be somewhere around 50 to 60, maybe 70 cases in Collier County, and the week after we'll probably be into the hundreds. And it seems to be on a cycle of about every 7 to 10 days it's increasing by a factor of 10. Remember that logarithmic scale we've been talking about? That's basically about it multiplies by 10 on a scale that fast. So I'm going to stop probably coming into campus and do a lot of my teaching from my house. Let's see other questions. And answer your questions, no, Freddie, I'm not going to be giving in person. The whole point, I know there are plenty of faculty members who are still allowing in-person sessions. My view is, if we're going to have social distancing put in place, I have no desire to be locked in a room with anybody. I have my family, and my mother-in-law lives in town, so we want to be there for her in case she needs us. Other questions? All right. If there are no questions, let's see, what time is it? We have about a half an hour left of class, so that was a little over half an hour. So I'm going to attempt at the PowerPoint, and we'll see how this works for a larger class now that everybody in the university is sharing. So I won't be able to read your comments right now when I'm in this mode. All I can see is the PowerPoint presentation. So if you need to make any comments while I am, in PowerPoint mode, you will need to let me know, turn on your voice and your audio and let me know. All right, so I'm going to start here where we left
Dr.
off.
Barbosa, are there
Yes.
more sheets? Are there more problems? Because the sheet that you handed out a couple days ago, we just finished it. Are there more problems on the sheet, or are we done there?
There's another sheet in my box. I put it in there last night just before I left, and So there is one sheet left in my box, but there are going to be a couple more problems for this session. You might need to just write it out for now. In the end, I know I said I would probably leave it in my box yesterday, Freddie, but as I'm keeping track of this, there's likely you're going to have to start printing these things out on your own. Yeah, because eventually we're going to be at a point where most of you are probably going to leave and go home. At least that's my prediction. I predict the campus isn't going to open back up. That's just me. I could be wrong. I hope I'm wrong. I don't think I'm wrong, though. That's just not me being overly confident. I just think just what's happening everywhere else is going to continue to happen here, too. All right. Other questions? All right. So we left off, we were talking about strong versus weak acids. And obviously, let me see if I can get this here. Laser pointer. So there's a laser pointer feature here. So we're talking about strong versus weak acids, and I think it might have been a little further ahead, but I'm going to start here anyway. Where the strong acid, right, we have complete dissociation occurs when the amount of acid that you put in, HA, is equal to the number of protons that you form at equilibrium. But actually, it shouldn't even say equilibrium because it's not really an equilibrium. It's everything's going over to completion, right? So in this case, we have, right, it's going to take me a little while to get used to going back and forth between pen and laser pointer. But you're going to have HA as an aqueous solution. It's going to completely dissociate to give us H plus A minus as aqueous solutions. Right, so you have complete dissociation, single-headed arrow. Whereas with the weak acid, we have a weak acid HA. And that's just the difference is it's going to be in equilibrium with H plus and A minus. Right. So the only difference between the two are the equilibrium arrows versus the one-sided arrow. And we talked in the last class about the fact that we saw, this zinc dissolving very rapidly with hydrochloric acid down here, right, where you place the zinc in the hydrochloric acid solution versus the acetic acid solution, and you see very rapid and dissolving of the zinc in the hydrochloric acid solution just because there are more protons, right? We have a lot more protons present in solution of the strong acid than we do for the weak acid. And we work through the weak acid calculations just like we had here, where we have the we're calculate, it says to calculate the pH and percentage of HF molecules ionized in a 0.1 molar HF solution, where you'll have during the exam, in the future, you'll have the appendix will be available to you. You'll have to look up your Kas. So you look up Ka of hydrofluoric acid at 6.8. And then we're just going to, again, run this as just like we do in previous equilibrium problems. You're going to write the chemical equation for the equilibrium, and you're going to tabulate the known and unknown concentrations of all the species. And then you're going to substitute the equilibrium concentrations into the equilibrium constant expression and solve for the unknown concentration of H+. So you set up your table, you have your ice table, right? And the reason we're calling it ice is because we have our initial, then our change, and our equilibrium, right? And with the ice table, you can see here, we know in this problem we have 0.10 molar. We're going to start with no product, right? No H plus and no F minus. We know that at the end of this, we will have a total of X, right, of both the products. So we're going to be adding x, our change is plus x, and for the products, and minus x for the reactant. So we have our equilibrium concentration is 0.1 minus x. Then plug these numbers from the equilibrium into our Ka expression down below. So we end up with x squared over 0.1 minus x is equal to 6.8 times 10 to the minus 4. Again, like I said, we worked through this problem before, right? And then we try solving this equation using the approximation, right? We make the approximation that the minus x is much, much smaller than 0.1. So we assume that 0.1 is the only part of the denominator. So we end up, after solving, we work through this, right? You would work through and solve the x squared, solve for x squared, and then, take the square root to get x is equal to 8.2 times 10 to the minus 3. And then you would then go back, and what I showed you was that we would take this and you would determine that whether or not that 8.2 times 10 to the minus 3 is less than or greater than 5% of the 0.1 molar. And you'd see that it is. You could do the math. And with that, that tells you that you actually need to go through and run through the quadratic equation. So we walk through and we solved and rearranged the equation to set it up in the quadratic formula. And we pulled out the information from the quadratic equation, plugged it into the expression on the right, and solved for x and showed that x was equal to both 7.7 times 10 to the minus 3 or minus 8.3 times 10 to the minus 3, right? Because we're doing plus or minus. So we get both answers. And obviously, the negative number is not chemically reasonable. So we then just use 7.7 times 10 to the minus 3 molar, set that equal to our H plus concentration. It's also equal to our fluoride concentration. And then we simply plug that into the pH equation to get a pH of 2.11. And then to finally get the percent ionization, we simply take that 7.7 molar that we set, place that into the equation here. It's the percent that is ionized, divided by the original concentrations, 0.10 molar, multiplied by 100%, and we end up with percent ionization of 7.7. Anybody have questions on that particular part? All right. So I see a question from Annie. The exam covered everything up to percent ionization. She's asking about the exam was asking that covered up to everything in the percent ionization section, which is, let me see here. Which was back, I want to say percent ionization we finished on slide 41. So up through slide 41. The Excel question, we probably will have something with Excel. I'm not sure how. I have to figure out the Excel on the exam. So Freddie's asking whether or not we're going to use Excel for the exam. And I have to figure that out. I'm not sure how I want to have that done. Make it a bonus. Bonus questions. There's no difference between a bonus question and a regular question, Freddie. That's the illusion that faculty members give you. You get a bonus question, that's no different than scaling in the end. Right. All right. I'll try to figure out. I'll give you updates hopefully by the next class. I spent my entire weekend basically trying to prepare for today's class and figure out all the software, learn the best ways to do everything, posting things. So I'm just catching up to myself. Brian's asking about whether we're going to have that meeting beforehand. So I was planning on having an online session. So we had scheduled it for in class. I think we scheduled it for 7 to 8 p.m. on that Wednesday beforehand. So I'm planning on just being online from 7 to 8 during that. The labs, we'll let you know. Dr. Tonga and I are going to talk today after we're both done with classes. So we're not sure what's going to happen with labs yet. We're trying to figure that out. So there may be, it may just be providing you data and you'll be running through the calculations, but we're not sure yet. Right. Going to get back to the slides. So polyprotic acids. So polyprotic acids have more than one acidic proton. It's always easier to remove the first proton than any of the successive protons. And if the factor in the Ka values for the first and second dissociation has a difference of 3 or greater, the pH generally depends only on the first dissociation. So what does that mean, right? We have our examples of polyprotic acids, right? If H2SO4, right? H2SO4 can dissociate to give us H plus HSO4 minus. Right? That HSO4 minus can then dissociate in another step to give us H plus SO4 2 minus, right? So a polyprotic acid, when we're talking polyprotic, it's any type of acid that is able to donate more than one of its protons, right? In this case, sulfuric acid has 2. You know, there are many of them. It could have been H2SO3, could have had carbonic acid, H2CO3, right? There are various acids that are polyprotic acids. They have more than one acidic proton. So, you know, the first step, right, step 1 here, is always going to be easier than step 2, right? Because the first proton is the most acidic proton. And what they're saying is if we're looking at the Ka values of each of these, so H2SO4 and HSO4 minus each have individual Ka values. And if that Ka value has a difference of 3 or greater, right, 3 or greater in difference in Ka, then the pH is only going to be dependent on the first one, right? So the pH will only be dependent on the first one if the Ka is greater than 3 or more. So here's some examples of polyprotic acids. Here you have ascorbic acid here. Right? Ascorbic acid is sitting here. We have it's an organic acid, one of those dietary acids. Right? Our first Ka is 8.0 times 10 to the minus 5th, and we have the second Ka at 1. Put the laser pointer on. Right, we have the first Ka is 8.0 times 10 to the minus 5th. The second one 1.6 times 10 to the minus 12. And you can see here we have a difference of larger than a factor of 3. So you can see that tells you that your acidity of your solution is going to be completely dependent on the first proton coming off. Carbonic acid, right? Carbonic acid, you can see here, right, when we're talking about, let me go back. Carbonic acid, we have 4.3 times 10 to the minus 7th, versus 5.6 times 10 to the minus 11th, you can see again, carbonic acid, the pH is going to be solely dependent on the first dissociation constant, the first proton coming off. Citric acid. Right? So citric acid, on the other hand, right, we have a pH, our pH is, when we're looking through this, let me look up one quick thing here. And I think I'm going to double check something. But when we're looking at the citric acid again, we have 7.4 times 10 to the minus fourth and 1.7 times 10 to the minus fifth. You can see that you have a third Ka of 4.0 times 10 to the minus 7, right? So we're talking citric acid. You have 3 different Kas, and obviously the Ka3 isn't going to have any effect on the pH of solution. The Ka of the first acid is going to be the dominant one, controlling the pH. And I want to double check, but the reason I keep flipping back and forth, because it says here that if it has a difference of 3 or greater, that the Ka value is only dependent on the first. And I want to say that what I think they meant is a factor of 3. So I believe in citric acid's case, because we have 10 to the minus fifth here and 10 to the minus fourth, that the first and the second Kas are both going to affect the pH of the solution. And I just want to double check, because what the slide says and what I believe to be true is opposite one another. So I'll have to get back to you on that. You see oxalic acid, again, another one that has a factor of 3. So I believe both of these acids are going to have an effect on pH. Phosphoric acid, down below, we have a difference between the first and the second is greater than a factor of 3 in the exponent, in which case only the first is going to affect pH. Sulfurous, same thing. Sulfuric acid, the one that I showed you on the previous slide, it's considered one of the strong acids. So the first deprotonation or loss of a proton is a complete dissociation, whereas the second one is equilibrium. Right? So that's why it says large here. The reason it says large is because the first one is essentially not in equilibrium at all. And then last, tartaric acid has a difference of less than exponents of 3. So both the first and the second will have an effect on pH. Anyone have questions on this section so far? If not, we'll work through a simple. Yeah, so question is difference of 3, and this is what I need to double check, and maybe I'll just look very, very quickly, just because I want to say these slides are incorrect. I'm pretty sure the slides are incorrect here, and I just want to make sure. I apologize. I usually look over the slides before class, and I didn't have a chance to today or this weekend. Still trying to catch up, just like all of you are. Let's see. There we go. Yep, there's what this should read, and we'll go back to the slide. I was just double checking. So what this should say here, oops. Right. So there's going to be a correction here. So this is not supposed to be 3 or greater. It's supposed to be a factor of 10 to the 3 or greater. So a factor of 1,000. So if there's a 1,000 times difference in Ka, right? So that's equal to 1,000 times greater. If it's 1,000 times greater in Ka, then you're 1,000 times, or less, basically, then you're going to have the Ka1 and Ka2 are both going to affect the pH. So that's what I was talking about here. If I go back, let me turn my laser pointer on. Right, in these examples, 10 to the minus 5th versus 10 to the minus 12th, right? We have a difference of 7 between the two of them. Right, a difference of 7, 10 to the 7th in between the two, so only the Ka1 is going to affect pH. Whereas down below here, we have 10 to the minus 2 and 10 to the minus 5th. So we have a difference of 10 to the 3 between the two. So both Ka1 and Ka2 are going to affect the pH of the solution. And then, other examples, say, down here, right? So tartaric acid, 10 to the minus 3 versus 10 to the minus 5th. So because 10 to the minus 3 and 10 to the minus 5th, they're only a difference of 10 to the minus 2. So both Ka1 and Ka2 are going to affect the pH of the solution. Does that make better sense? Right. So Ka3, so when we're talking about, Annie has a question about Ka3 and where that's coming from. So let me give you an example here. So if we take phosphoric acid as an example, we're going to go through the example problem on the next slide. But if we just, from phosphoric acid, right, oops. So we have H3PO4 is going to be in equilibrium with H plus H2PO4 minus, right? So this is going to be Ka1, the first dissociation constant. Well, H2PO4 can then also dissociate further, right, to give us another H plus HPO4 2 minus. This is going to be Ka2. And then HPO4 2 minus can then dissociate a third time to give us another H plus the PO4 3 minus. And this is going to be Ka3. Does that make sense for phosphoric acid? So when you're talking Ka1, Ka2, Ka3, right, there are dissociation constants for each one of these steps. Every single time you have a dissociation that occurs, there's an equilibrium of constant associated with it. And in the case of phosphoric acid, because the first and the second are greater than a factor of 10 to the 3 from each other, the acidity of phosphoric acid in solution is only going to be dependent on the Ka1 in solution. The second, so all of the protons that affect the pH are just going to be the protons from this first association. None of the others. So this entire right-hand side from here, Ka2 and Ka3 will not affect the pH of a solution when you dissolve phosphoric acid into acid. All right. So sample problem. So the solubility of carbon dioxide in water at 25 degrees Celsius and 0.1 atmospheres is 0.0037 molar. The common practice is to assume that all the dissolved CO2 is in the form of carbonic acid, H2CO3, which is produced in the reaction. So here's the reaction, right? But we have carbon dioxide, right? Carbon dioxide here reacts with water when you dissolve it with water to form carbonic acid as an aqueous solution. So to ask the question, what is the pH of a 0.0037 molar solution of carbonic acid? Right. So what do we need to do first? First thing we need to do, because we have to look at the Kas of each of these, right? We take a look at carbonic acid. We find it in the table. Carbonic acid is sitting here. And we have a Ka1 of 4.3 times 10 to the minus 7, and a Ka2 of 5.6 times 10 to the minus 11, right? Because they differ by more than a factor of 3, factor of 10 to the 3, the pH is determined by considering only the Ka1. So this is going to be straightforward. Ka1 is going to be the only, part of the calculation in order to calculate pH. We're going to treat it just like a monoprotic acid. So just like in the other examples, we're going to enter in our initial concentration of carbonic acid. We know that our final concentrations of X are X for the proton and for the bicarbonate ion. We initially start with 0 of each of those, so we see a plus X change for each of these. Our change is going to be minus X for carbonic acid itself, so we end up with an equilibrium concentration of 0.37 times 10 to the minus X for our equilibrium concentration. So we then plug the information into our equilibrium constant expression, right? We have our products divided by our reactants, and that gives us our X squared over 0.37 minus X is equal to 4.3 times 10 to the minus 7. 4.3 times 10 to the minus 7 just came from the table, right? That's just right here. Now steps aren't shown here, but you would basically solve this, rearrange this into the quadratic equation formula, and take the quadratic equation formula, solve for X, and you can get X is equal to 4.0 times 10 to the minus 5, right? And I show all of the work here, right? So you have 4.3 times 10 to the minus 7 is equal to X squared over 0.37 minus X. So we just, move the 0.37 minus X over to the other side by multiplying both sides by that. You end up with the formula here. Distribute the 4.3 times 10 to the minus 7 into both sides. You end up with the equation down below here. And then you want to move X squared, the remainder of this equation here, to the other side with X squared to set everything equal to 0. So all we did was rearrange. And now we're set up in the ax squared plus bx plus c equals 0. Plug that into the quadratic equation and solve for x. And this is how we got to 4.0 times 10 to the minus 5. So this is probably going to be one of the last times I show you the work for solving the quadratic equation. So you want to make sure you understand how to do that. And if you don't, make sure you get help from myself or tutors and practice working through that. This is, kind of some of the basic algebra that you should know beforehand. So if you're having any types of struggles working through this, please let me know. All right. So alternatively, because the Ka1 is small, we can make the simplifying approximation that X is small so that we can simplify the 0.0037 minus X and set it equal to 0.37. And if you plug that into the equation right here and then solve, solve the equation, we end up with X is equal to the proton concentration, which is equal to square root of 1.6 times 10 to the minus 9, which is 4.0 times 10 to the minus 5. So if we compare this, it's the exact same answer that we got back here by plugging into the quadratic equation. So I can't remember who was it in class that basically mentioned that we could probably go either way and have either, if you always solved using the quadratic equation, you get the right answer. So that is true. This can be proven right here. So if you always use the quadratic equation, you'll get the correct answer, or you can simplify. All right. So it says because we get the same value, to two significant figures. Our simplifying assumption was justified, so the pH is therefore, right, we plug the proton concentration into the pH equation, and we end up with minus the log of 4.0 times 10 to the minus fifth, which gives us a pH of 4.40. And remember, we have two significant figures. The 0.40 is because we have two significant figures in our proton concentration. And one last comment. It says if we were asked for the carbonate concentration, we would need to use the Ka2, and so in order to illustrate that, equation, right? So we have a second dissociation. So if we go back a couple slides here, right, we have our initial concentration of, carbonic acid, which dissociates to give us our proton plus our bicarbonate anion. If we go, let me go back one more slide. So if in this equation here, in the problem here, if we were instead asked to determine, instead of asking what the pH of the solution was, if we were asked to determine what the solution of carbonate anion was, we would have to then take the bicarbonate anion and dissociate it one step further, which is shown here, right? So we would take the bicarbonate anion, it would then dissociate one step further to give us more protons plus the carbonate anion. So we have two steps, and we know from the calculations during the last part, right? So if we go back here, right, we know that X was equal to both our proton concentration and the bicarbonate concentration, and both of them are equal to 4.0 times 10 to the minus fifth. Well, we can then plug that information in, right? So we have our second dissociation that occurs where the bicarbonate dissociates to give us protons plus the carbonate, but we start our initial concentration here with the bicarbonate concentration that was formed in the last from the last calculations, but we also have protons present. So we have two initial concentrations that we know, and only one is equal to 0. And we know that now the change, instead of X, we're going to use Y as our variable. So we're going to see an increase of Y of both proton and the carbonate. So we end up with Y here, whereas we end up with 4.0 times 10 to the minus fifth minus Y for our bicarbonate concentration and plus Y for our proton concentrations. So if we again make the assumption that this Y is very small, we can essentially remove the Y from both the proton and bicarbonate concentration in the equation. So we then simply plug into our Ka2, right? You can see the Ka2 is just dependent on products divided by the reactant, right? So we enter in our 4.0 times 10 to the minus fifth times Y, right? So it's these two, divided by our 4.0 times 10 to the minus fifth, which comes from our initial concentration here, and set that equal to Ka2, right? The Ka2 came from the table earlier. And we solve for Y, which is equal to the carbonate concentration, which is 5.6 times 10 to the minus 11. So you can see here that there's an extremely tiny concentration of carbonate present, right? If you think about the number of protons of 4.0 times 10 to the minus fifth that we have in solution, we are a factor of 10 to the sixth smaller of carbonate ions. So there's very, very little carbonate present in solution. Most of it is going to exist in the form of the bicarbonate ion. So there's my slide. It says the value for Y is indeed very small compared with 4.0 times 10 to the minus fifth, showing that the assumption was justified. It also shows that the ionization of bicarbonate is negligible relative to that of the carbonic acid as far as production of H plus is concerned. However, it is the only source of carbonate which is a very low concentration in the solution, and the calculations thus show that in a solution of carbon dioxide and water, most of the carbon dioxide is in the form of CO2 or carbonic acid, and that only a small fraction ionizes to form the protons plus the bicarbonate anion. An even smaller fraction ionizes to give the carbonate anion. Notice also that the carbonate concentration is numerically equal to the Ka2. Right, so if we go back here, all they're saying is the carbonate, when you have a very small concentration that's going to be present here, this carbonate concentration ends up being exactly equal to the Ka2. Why is that? Because these two cancel, right? So, right. So Jason's asking, is the exam still scheduled from 8 a.m. to 5 p.m. on Thursday? Currently, we're planning on it. Dr. Chong and I are planning on that. I don't know if things will change or not. We were discussing, we're still in discussions trying to figure all that out, but that's the plan right now, is to stick to that schedule. All right, I'm going to end here from the slides. Obviously, we're almost done with the class time. Does anybody have any other questions? In the next class, we'll work through some additional problems. Andrew, exit this here. Any more questions? Hope everyone stays safe. How many people are still on campus? One, two, three, four. One person leaving. So a lot of you are still sticking around, huh? You're hardcore. Not afraid of the disease. You're not impervious, at least according to a recent study. So just take care of yourself. And your friends start coughing, go quarantine yourself in your room. Stay safe, stay healthy. All right. Thanks, everyone. Hopefully this works out for you. If you're struggling with this type of class, please let me know in a private email or something, and I'll see what I can do to try to help. I'm going to turn off the recording now, so it should be ended, and hopefully I'll be able to